like expressions, and then you will end up with nice simple integral. Okay, let's see. Oh, okay. First of all, do we remember this integral? I think I mentioned something like inverse sine and inverse tangent. Okay, we remember inverse sine of x and inverse tangent. That means this is the formula that we should know. Let's say this way. Yeah, this will be one of the list of the reference page, all of the formulas. Okay, that means we definitely know this, that integral of 1 over square root of the quantity 1 minus x squared dx, it's inverse sine. But what I would like to do, since we know the answer, I would like, okay, too fast. I would like, okay, to actually to derive this, the whole answer. That means I will start with this integral, okay, and I will pretend that I don't know the answer, and I will do something. I will apply some algorithm, some method, technique of integration, and hopefully we will get inverse sine of x. Okay, that means we will try to get this answer. But as I said, we don't have to later. If you see this particular integral, you can say right away it's inverse sine of x. Okay, that means what I will do, I will try to introduce a new variable, which will be theta, and I will replace x and dx with theta, d theta. That means what I will do, this, I suppose to show you this. Instead of x, okay, I will put sine theta. I will tell you later why I did this. And then dx is cosine theta. And we can nicely see, that means now I'm like, it's kind of like a reverse substitution. I have square root of 1 minus x squared, but my x is sine. Then I have sine square theta. And dx is cosine theta d theta. That's when I have to put cosine theta d theta. Yeah, it's like the other way substitution. Okay, then we also, and now let's look what we have. And as I said, looks like we complicating, but let's see. 1 minus sine square theta could be rewrite as a cosine square theta. And now, do you think I can simplify square root and the squared expression? I can simplify, yes, thank you, Heather. That means I can definitely do this. Mathematically, we have to be always careful because when I have, let's just say this, square root of x squared, this is x, but only if x is positive. Because if x is negative, then I have to involve some absolute value or maybe negative sign. But if this quantity is positive, I can simplify. I can use my algebra property. And actually, because we dealing with the inverse function, that's what we will do. Quantity like cosine will be always positive because we can see that's the domain. And cosine function, when I draw a cosine between negative pi over 2 and positive pi over 2, it is positive. It is above the x-axis. Okay, that's cosine theta. Okay, that's we just yeah, making sure. And then cosine over cosine is just 1, and integral of 1 theta, yeah, is just theta plus the constant c. The only thing that we have to do, we have to get back and have our final answer in terms of the original variable, which was x. That means looking at this, because that was my substitution, looking at this, we will rewrite if x equals to sine theta, then inverse sine of x equals theta. Yeah, we know it's just the inverse definition. And then I can write theta is inverse sine of x. And that's what we were expecting. Okay, that means that we can see we did start with the formula and we knew it. We knew it that that's the point. Okay, that means this is the way to do it. But let me explain one thing. Looking at this original integral, what I saw. Okay, in this integral, I see the square root expression. Okay? And it's under the square root, we have 1 minus x squared. That means, of course, having this algebraic function, it's not easy to integrate. Okay? That means we will know that seeing this square root expression, we have to apply the trigonometric substitution. That's what we did. And now, since I have 1 minus x squared, would be nice to have 1 minus sine squared of theta. Yeah? That's the reason that I actually choose x to be sine theta. Because you may notice 1 minus sine squared theta, the expanded form, I managed to rewrite as one single form, and I managed to remove the square root. Yeah? That means this is the point. Based on the trigonometric identity, I knew it that I have to put sine theta, because I know that I will cancel out the square root expression, and that's the point. Yes, we can use cosine, of course. We can use cosine because cosine square, but for some reason the cosine and then it will be, let's say it's easy, you can use it. You may have probably some negative sign and some like opposite. I can just make maybe the note that it's much easier to use sine function. Okay, and even the textbook is suggesting that always use x equals to sine theta. But you're right, you can use cosine and then we will have sine squared and then we will have sine. Yeah. But you can even look at this, cosine theta over sine theta. We can still integrate, but will be few additional steps. That means it's easier to use sine. But my point was to tell you why we're using sine, because we managed to get rid of the square root expression. Okay, it means now, this is just like the slide, like the theoretical part. That means what we did. Okay, we will, based on the expression, okay, we will pick the appropriate trigonometric substitution. That means we will, x will be replaced by sine theta, tangent theta, or secant theta, the only 3 options. Okay, and of course the choice is based on the trigonometric identities. I have the summary for you. But we can see we kind of call this inverse substitution, because we're not replacing, like we're not giving you some formula of x. We're actually replacing x with the formula of the new variable. Yeah, we can see it's like x is on at different like position. Okay? And that means having a function, we will say that x is defined as a new function in terms of theta, and of course respectively dx will be computed. Okay, like we did, x was sine theta, that means this will be sine theta, and dx was cosine theta d theta. Okay, that means that's what we will do. We have to find out a substitution. Okay, and now let's see these 3 types. That's the important slide. That will be for you the guide, and then you can integrate everything. That means the first that we did, okay, was number 1, 2, and 3. Okay. That means one more time, you will see the integral and you will see the square root expression, the radical expression. And most general form will be, because we did have 1. Yeah, 1 is 1 squared. But the most general one, you may actually see a quantity. Okay? Would be nice if this will be like a square quantity, like 1, 4, 9, 16, that doesn't matter. Even if it's different, we can still work it out. But you will see a constant minus x squared, minus x. Okay? Then you will always do this substitution. Okay? That means, for example, if you will see 4 minus x squared, what substitution you will do? 2 sine theta, because that 4 is forcing me to have this additional coefficient, 2 sine theta. Okay, and now you can probably guess why. Because when you can imagine 2 sine theta, I can substitute instead of x. Okay? I can maybe work just the first one. That means we will have 4 and 2 sine theta squared. And I will square this. That means you can see I have that 4. 2 squared is 4, sine squared is just sine squared. I can factor out 4 and I have 1 minus sine squared theta. Square root of 4 is 2. How can I rewrite 1 minus sine squared? Yeah, we can see that. Yes, thank you. That's the point, because I will end up with cosine squared theta, and we know that we can simplify. Okay, that's when you can see that's the point, because of these identities. Yeah. Now the second one, when you will see like a constant, okay, plus x squared. Okay, plus. Then the same idea. If this is 4, we will like have 2. If this is 9, we will have the coefficient 3. But if it's plus x squared, the substitution is tangent theta, a tangent theta, because we can see 1 plus tangent square is giving me secant square. And if we do have this square root, we can simplify. Yeah, the same that I did. That's the point. Yeah, to not have the square root. And the last one is actually make sure that you can see the difference between the first one and the third one. We do have x squared, positive x squared, minus a constant, minus a squared. A is constant. Okay. Then we will do secant theta. And that's the only free option. And why? Because we can see secant square theta minus 1 minus the constant is tangent square. And I will be able to simplify, yeah, if I have the square root. Okay, that's it. Please remember, quantity minus x squared, it's sine theta involved. Like a constant plus x squared, positive constant, positive x squared is tangent theta. Positive x but minus a constant is secant. Okay, that means that's the only thing that we have to know, and then we can integrate. Let's integrate. Let's integrate one each, okay? And then you will practice. Okay. Evaluate the integral of the square root of 1 minus x squared over x squared dx. Just one more comment. You may always try if the normal U substitution works. Okay, it's really rare. Probably you have to use the new trigonometric substitution, but I'm just to like, because sometimes you can, and you can probably do the whole process through the trigonometric substitution, but then at the end you will realize, oh, just the U substitution works. Just always. Actually, having any integral, I will always check the U substitution, because sometimes it's too fast. Okay, Abdallah is telling if only it was x in the denominator. Actually, not really, because x in the denominator, it will be 1 over x. If the integral will look like that, if I will flip the fraction and then have x, this is good for the U substitution. Do you see? Yeah, everybody can see, because I can let u to be, of course, the inner quantity, and then x dx to 1/2, we will work it out. Yes, okay. That's what you can see. This is good for the u substitution. Okay, but we do have different one. That means, first of all, what trigonometric substitution we can make? It's sine theta. Excellent. That means we will do sine theta x, and dx is cosine theta d theta. Okay, I don't know if I typed the entire solution, but yeah, I can always write. Okay, that's me. Now let's make sure that we will replace everything. X, dot x, and dx. Okay, everything has to be replaced with theta. Sine square, correct, another sine square, because that was x, and dx, it's cosine theta d theta. Okay. How can I rewrite 1 minus sine square theta? We just did this. Is cosine square theta. Oh, of course, we can simplify, because the square root and the square is just cosine. And then cosine times cosine is cosine square theta. Yeah. And theoretically, this is supposed to be the easy integral, but I think it is easy. Cotangent square theta. Do we know the antiderivative right away? What function has the derivative cotangent square? Or maybe we don't know. Oh, no. We know secant square. Oh, okay. I think I've got, okay, I will erase this. We know this function, and we know this function. That's what I meant. Tangent square and cotangent, we don't know. Okay, what is integral of secant square? It's tangent theta, because derivative of tangent is secant square. And cosecant square, it's negative cotangent theta. Okay, that means that's what I meant. Yeah, please forgot what I asked. But can we rewrite cotangent square in terms of cosecant square? Yeah, I think we can say cosecant square minus 1. Yes, thank you, Heather. That's me now. Now we can use the direct antiderivatives for cosecant square theta and 1. Yeah, that means that's the formula. We know this Pythagorean identity. And integral of cosecant square is negative cotangent. We just had this. And integral of 1 d theta is just theta. Okay, I will erase this, or maybe I can keep it actually, because we need some additional exercise. Okay, but we remember the first slide. We have to rewrite, the final answer, we have to present in terms of x. That means what we will do, we can rewrite theta quite easily, because, oh, too fast. I think I typed it. Okay, I can write it, because theta will be just inverse sine of x. That's good. But we also have cotangent theta. Okay, and the only, my substitution was sine theta was x, right? And you probably remember the triangle method. Oh, we don't remember. We maybe remember from the trigonometric. I can show you. That will be crucial and important. Let me write too many arrows. Let's say one more time. Sine theta equals to x. And as a ratio, I can say x over 1. Make sense? And my best friend, the right triangle, that's the angle. And if sine is defined as a x over 1, do you remember the ratio in the right triangle? Opposite, hypotenuse, adjacent. Which side will be x? Which side will be 1? X over 1. The SOHCAHTOA, or I don't know if I'm... X is opposite, yes, opposite over hypotenuse. Really good. Thank you. That means x, we can see opposite over hypotenuse. And now, if this is x, this is 1, do you think we can compute the third side, the adjacent in this case, from the Pythagorean theorem? Yes, it will be x squared plus this squared equals to 1 squared, then 1 minus x squared square root. Excellent. Having the full triangle, I believe we can read cotangent. Who can tell me what is cotangent theta? Looking at this triangle. Cotangent is, I think I know, but I'm waiting. It's the adjacent, really good. 1 minus x squared square root over opposite. Thank you. Okay, that means this is, we can see that's additional like exercise. And I believe, oh, okay, negative came from the formula I just, yeah, and this is my sign. That's, we can see that that's the part, and we work it out. Okay, that's me, please always use the triangle method. One thing, it's like a small hint. Do you see this? We did compute the third side. It was the adjacent. And can you see what we've got? Square root of 1 minus x squared. Do you see the same square root in the original integrand? And that's always the case. Okay? When you will compute at the end, like you will build the triangle, you will find the third side, and if you will have square root, always must be the same like the original one. I mean, like in the original root, in the original integrand. Okay, if it's different, probably we make some mistake, then we can correct ourselves. Okay, let's keep working. I think oh no, I didn't type. Good, excellent. Okay, another integral. Integral of 1 over x squared times square root of x squared plus 4. Do you remember? I know that we still, it will be tangent, yes, but what coefficient in front of the tangent? We have to put 2 because we do have that, yes, we can see. So let's see, yes, 2 tangent theta. And x is 2 tangent theta, that we can see just based on the formula. And then dx will be 2 secant squared theta d theta. Let's rewrite everything. X, we have to rewrite x, it will be x squared, of course. 4 tangent square, that x squared, 4 tangent square, and please remember dx. Okay, dx is 2 secant square theta d theta. Okay, and did I type? Okay, I did simplify. Let me write maybe here. Let's take care of just this square root because that's the point. I can maybe write here 4. I can factor out tangent square theta plus 1. You probably noticed that's the reason that we need this additional coefficient. I know it will be simplified like that, but let's do step by step. And then square root of 4, square root, tangent square theta plus 1. Who can tell me the trigonometric identity? Secant square, thank you. And then this is 2 and this is secant. The domain is letting me to simplify. Okay, I do have 2 secant theta. That's when you can maybe do on the side and then we don't have to carry like the entire formula. Okay, Can we simplify something? 2 and 2 square and secant. That means we will have 1/4, yes, thank you. Secant theta will stay and tangent square will stay. And what we can do, because I don't know if we see right away, probably not. Let's try to rewrite in terms of sine and cosine. If you can see some formulas, you can use it, but I think will be easier if we will rewrite in terms of sine and cosine. But I don't know if this, maybe that's too fast. Let's see. Okay, secant is, we have secant theta over tan square theta. And what I did, secant is 1 over cosine, and yes, tangent square theta will be sine square theta over cosine. That means I have to flip it. And then cosine and square, that means cosine theta over sine squared. I hope now it's not too complicated. Okay. We still have trigonometric integral. What do you think? How we can integrate this? Cosine theta over sine square. We can, that's what cosecant, cotangent, we can do this way. Did I use the use? I think I used the U substitution, but okay, let's ignore my typing. We can do this way. I think or maybe I can show you both ways. That means cosine theta, sine theta, and the sine theta. Correct? And 1 over cos, maybe 1 over sine. 1 over sine is cosecant. Cosine over sine is cotangent. And do we know the antiderivative for cosecant cotangent? What function has derivative cosecant cotangent? Yes, it will be negative cosecant theta, because derivative of cosecant theta is cosecant cotangent. Of course, negative has to be placed. Yeah, we can do this way. If you can see underneath, I think I use the U substitution. That means another way is to use the U substitution. You can see, I let U to be sine theta, okay? And then this is du. That means 1 over U squared. Yeah, if you will think 1 over U squared. And then derivative of, antiderivative of 1 over U squared will be negative 1 over U, which will be negative 1 over sine, which is cosecant. That means you can get the same thing, but I will not repeat since we did the trigonometric way. Okay, but just in case, you may have 2 different ways. Yes, we definitely have to practice I think beginning, yeah, because Heather is like, yeah, making good statement. I think beginning of my last week session, 7.1, I think we have like 2 or 3 slides with the formulas. That means please, yeah, please revisit the slides and then you will have all of the formulas. I think I can also put like the page with all of the formulas that we have to know, and that will be helpful. Okay, I will type all of the formulas for you. Okay, and then I will post in this lesson, okay? Yes, yeah, I know. It's nice to have, and then you can print it and have somewhere, yes, near to you for the next few weeks. Okay, but what we have to do, we still have to yes, we still have to rewrite in terms of x. Okay, that's me. Let's see. We need cosecant. I can maybe rewrite -1 and then cosecant theta. Okay, that's me. What was my substitution? We building our triangle. Tangent theta, because we have the coefficient, we will flip. That means tangent theta is a nice ratio, x over 2. Let's build a triangle. Who can tell me where is x, where is 2? You have to tell me this. X is opposite, excellent, and 2 is adjacent. Now is the moment to compute the third side. In this example, is the hypotenuse. What will be the hypotenuse? That's really good. It will be x squared plus 2 squared. Thank you, Remy, and thank you, Abdallah. Good comments. The same square root that we have in the original integrand. Okay, and we need cosecant. Who can tell me cosecant ratio? Cosecant is 1 over sine. We can flip sine. You can tell me if I'm right. Yes, okay, thank you. You fast typer. Okay, that means I can maybe I can save my room. It means we will need square root of x squared plus 4 and 4x. Okay, that means this is the final answer. This is just the square root. Yeah, that's the final answer. That's we can see the triangle method, and we did have maybe like a little bit, yeah, like not complicated, but few different ways to solve this integral. Okay, let's solve another one. I think we will have, oh yes, I will remove that. Okay, another nice one. Square root of x squared minus positive x squared minus a quantity minus constant 25. It will be secant. What coefficient in front of the secant? 5. Really good. X will be 5 secant theta. Dx will be 5 secant tangent. That's the derivative, secant theta, tangent theta. Okay, let's replace everything. Oh, I didn't type. Maybe even better. Okay, x squared will be 25 secant square theta minus 25. Okay, and then will be 5 cube and secant cube. And dx, please do not forget dx. Dx is 5 secant theta tan theta d theta. Yeah, that's what I said. It's quite long, but we like the simplification. Yeah. Yes, thank you. It of course is cube. Thank you. Okay, let's take care of the square root. We have to simplify this part. I can write here. We will factor out 25. That's the reason that we need the coefficient. Secant square theta minus 1. And then square root of 25. And how can we rewrite? Yes, 5 tangent, because this is tangent square. This is 5 and this is tangent. Excellent. Let's write this. Actually 1 5 and 1 5. This will be 5 squared secant cube. Oh, actually even secant. I can. Okay, let's keep it. Okay, and then my numerator 5 tangent theta. Okay, what I can simplify? I can simplify this and this. Now I have square and 5 and 5. That's mean 1/5 stay. Tangent times tangent, it will be tangent square, and secant square. Now it's square, correct? Please check, because I don't want to miss anything. Tangent, tangent, secant is cancelled out, it's squared. Okay, that means this one we can Yes, because we can definitely rewrite tangent square as a sine square theta over cosine square theta, and secant is 1 over cosine. I will write the flip. Yeah, we can cancel out. We do have just, that's actually interesting integral, sine square theta d theta. This is important integral. It's also section 7.2. Do you possibly remember how to integrate sine square theta? We almost have one way. We have to use half angle formula. Okay? Yeah. No, we will not integrate by parts. If this will be inverse sine or inverse tangent, then it's perfect for the integration by parts. But this is just sine square theta and cosine square theta. We have to use half angle formula, which is 1 minus cosine of 2 theta, because that was half, over 2. Yeah, that means we did eliminate the square. We just have the trigonometric. 1/5 and 1/2 is 1/10. 1 minus cosine. Yeah, that's interesting because we do have, okay, integral of 1 theta is, integral of 1 d theta is theta. And now, what's the integral of cosine of 2 theta? It is sine of the same angle, and we have to divide because it's antiderivative. That means we're dividing by 2. Sine 2 theta over 2. We remember angle never change. It affects some coefficients and some additional numbers, but never change. It was cosine 2 theta, it is sine 2 theta. Okay, and one more thing. We will rewrite theta. Yes, we will need the triangle, definitely, but one thing, because the triangle will give me information about theta, and I have sine 2 theta. That means what we also need a double angle formula. Do you remember sine 2 theta is 2 sine theta cosine theta? Yes, yes, thank you. That's good. And then over 2. And now, of course, I can cancel out. And then I have to build the triangle, and I have to read sine theta and cosine theta. No more double angle. Okay. Let's see if I can squeeze the solution. First of all, secant theta is x over 5. We also need theta. That means theta, how can I write? It will be secant inverse of x over 5. That means I can put secant inverse of that angle, which actually I will erase because I need a space for the triangle. Okay, let's build a triangle. Theta. Okay. Abdallah, did you say 5 over x? Oh, cosine. Oh, okay, we can, yeah. Right away, yes, right away I can say x is, cosine, because you can simply flip, of course. 5 over x, but we still need sine. Okay, we still need sine theta. Okay, but let's build a triangle. Yeah, we have to definitely build a triangle. Okay, secant, x over 5. Who can tell me which side is x, which side is 5? Opposite, hypotenuse, adjacent. Adjacent is 5. That's actually good. Oh, I can't write 5. And the hypotenuse is x. Excellent. And then what will be the third side? The third side is the square root, of course, exactly the same square root. I can maybe write like that. X squared over 5 squared, which is 25. The same square root that we have in the original integrand. Okay, and now we need sine. Sine will be opposite. Okay, which is that square root over a hypotenuse. Yes, thank you. Okay, that means this, I can keep the green and then plus the constant c. Okay, that means this was quite challenge because we did, please remember what color I can use. Sine square theta, the only way, I mean for us, is to use half angle formula and also double angle. Okay, that means this is two formulas. If you will check section 7.2, my slides, I think I am solving this like that. Okay, that means let's maybe solve one more. Okay, and I believe we will be done with the integration through the trigonometric substitution, and you will see I will give you more practice, yeah, like the video with practice. Yeah, I call practice with Kasha. You probably watched some of them. Let's see what I have. I have this one. Oh, it's actually from, actually, do you think it's good for the U substitution? Or maybe I'm wrong. Yeah, I think yes, definitely. That means this is actually, that's the example that we can do too. I don't even, yeah. We can definitely, did I type? Yes. That means it's definitely square root of x squared plus 4, everything positive, then it's tangent 2. But we don't even have to go this way. I think we can just do the U substitution. Oh. Okay, that's what do you think? Shall we solve this way, or shall we solve through the U substitution? We can do both. Just the U substitution. Okay, that's me. Let's try. Let's just try the U substitution, which means we will let U to be the quantity inside, and du is derivative of this, and 1/2 du is x dx. I can rewrite x squared plus 4 x dx. 1 over u, and x dx is 1/2 du. 1/2 square root of u du. Square root of u is u to the power of 1/2. That means we will have 3/2 over 3/2. And then yes, we need a new limits of integration. That's the reason that I am not putting 0 and 1. New limits always. If x is 0, u will be 0 plus 4, 4. If x is 1, u will be 1 plus 4, 5. That means we do have from 4 to 5. From 4 to 5. And I can use from 4 to 5. Okay, I can flip this. This will be 1/3. And u to the power of 3/2 is square root of u cube. Makes sense? And also I can rewrite as a u square root of u. Okay, now let's substitute. Substituting 5 and substituting for lower limit and upper limit. This is just 5 root 5 minus 8. Please correct me if this is